Hi, welcome to Moo Moo Math. Today we're going to look at applications with oblique triangles, and we're going to be using the law of sine to solve these. So let's start off with this first example. Forrester's Smoky Bear is located at Ranger Station A and sights a fire in the direction 32 degrees east of north. So we've got a picture of Smoky Bear. He's at the ranger station and we have a fire. The fire is 32 degrees east of north. So north is our bearing and we're going 32 degrees east of north. Then we have Ranger Swampy Johnson located at Ranger Station B over here, which is 10 miles due east of Ranger Station A. So we've got 10 miles to the east. And he sights the same fire on a line of 48 degrees west of north. So again, your bearing is north and your angle is 48 degrees west of north. Find the distance from each ranger station to the fire. So we need to know what A is and we need to know what B is. So to set these up, we've got to look at our information. So we have 32 degrees here and we need to know this angle inside the triangle. So we know that these two angles create a right angle, so they're complementary. So I'm just going to take 90 minus 32 and find that interior angle. So that interior angle is 58 degrees. So this is 58. And I'm going to do the same thing on this side. I'm going to take 90 and I'm going to subtract 48 and I'm going to get my interior angle of 42 degrees. Now I have the angles inside the triangle and I have this side right here of 10. Now I don't have the opposite angle or the opposite side to angle A, little a, and I don't have the opposite side to B, which is little b. I don't have those, but I can figure out what C is because I do know two of the angles. So now I'm going to take 58 plus 42, and that gives me a sum of 100. And I know there are 180 degrees in a triangle. So let's subtract that from 100, and we get, of course, 80 degrees. So that means angle C is 80 degrees. Now I have an angle and an opposite side I can work with for the law of sine. And as you know, the law of sine is A over sine of angle A is equal to B over sine of B, and C is equal to the sine of angle C. So we're going to use angle C to the set C to solve for the rest. So since C is 10, I'm going to write that as sine of 80. And let's solve for A first. So A is this side over here. It's the distance from Swampy Johnson to the fire. So A is my unknown, and I'm going to take the sine of 58 degrees. Now let's grab our calculators, and we're going to do a cross product. So 10 times the sine of 58 is going to be equal to sine A times the sine of 80. So we're going to end up dividing both sides by the sine of 80 to solve this. So I'm going to type this left side in my calculator, which is 10 times sine of 58, all divided by sine of 80. So 10 times the sine of 58. Get that answer, divided by the sine of 80. And our answer is 8.6. So this distance is 8.6 miles. And now I need to solve for B. And so I'm going to use the same setup that I have here. I'm going to take 10 over sine of 80, which is C. And I'm going to set it up with B over sine of 42. And again, I'm going to do my cross product. So 10 times sine of 42, B times sine 80. So once you multiply those together, I'm going to take 10 times the sine. Oops, I got too many signs there. Let me clear one. Sine of 42. Get that answer. Divide that by the sine of 80. And that should give me my distance. 6.79, so 6.8 miles. So B is 6.8 miles. So the question asks, find the distance from each ranger station to the fire. So let's summarize that. Okay, so station A is 6.8 miles from the fire. And station B is, what was our answer to that one? 8.6 miles from the fire. There we go. Sorry, there's my other, so there's my final answer to this word problem. So there's my first example. Now let's talk about directions for a second. Directions are given in two different ways. So in that word problem, we saw the first option, 10 degrees east of north. So let's draw that. So if you're going to draw 10 degrees east of north, you got to think, well, north is my main direction. And if I'm going 10 degrees east of that, I'm going to go to the east 10 degrees. So there's where my angle would be. Okay, that's how I would draw my angle from a northeast southwest direction. So let's try another one. What if we're 25 degrees? Let me do this with lines. If I'm 25 degrees south of west, so if you think never eat soggy waffles for your directions, okay, we know this is west. If you're 20 degrees south of west, so I'm going to go to the south direction, and that's going to be 25 degrees here. So when you're going to draw these in word problems, you're going to have to draw some of the directions. Okay, there's a second option that we might have drawn, and this is east 50 degrees north. So instead of being east of north, it's actually your main direction is east, and you're going 50 degrees north of that. So on this one, you're going east, and then you're drawing 50 degrees north of that east direction. So there's how you would draw that. Okay, and the second one, your main direction is south, and you're going 32 degrees east of south. So from south, you would go 32 degrees east. So just a couple different ways you can write the directions. So this one to me is a little more straightforward. You're going east of the north direction or south of the west direction. This one, this is your main direction, and then you're going north of it. And then again, this is your main direction south, and you're going east of south. So just in the word problems, know there are two options, and know as you draw your pictures how to draw those. So let's look at a second word problem. So we have two observers that are 400 feet apart on opposite sides of a tree. The angle of elevation from the observers to the top of the tree are 15 degrees and 20 degrees. Find the height of the tree. So this one's actually a little bit more work. So let's draw ourselves a flat ground to put our tree on. Let's draw our people. So we have one observer over here looking up at the tree. All the way up to the top of the tree. And then we have a second observer on the opposite side of the tree. And they too are looking up at the tree. Okay, the first one has an angle of elevation of 15 degrees. The second one has an angle of elevation of 20 degrees. Now those angles of elevation are actually inside the triangle this time. Okay, and then we're told they are 400 feet apart. So this entire side is 400. Now, this tree is right in the middle of this large triangle. And we know a tree forms a right angle. So really, we just need this height or this altitude of the triangle. So we either need this, I'm going to call this side A, so that we either need a little a, and I'm going to call this vertex B. This side is B. I either need A or B. So I can choose which one I want to solve for. And so I'm going to solve for A. Now, in order to solve for it, I need to know what this angle is up here, or what is C. Well, I know this one's 15. I know that's 20. So I have 35 degrees already. So 180 minus 35. I'm doing this just so I don't make any silly mistakes. That's 145. I should know that, but 145. Now I can use the 145 with the opposite side, this entire side of 400. Then I can set it up as a law of sine with 15 and A. And that's going to give us part of this right triangle over here we need to work with, because we've got to find this height. And it's part of the right triangle. So that's what I have to work after I do this first step. So 400 is to the sine of 145. And that's equal to A over sine of 15. So by cross multiplying, I'm going to take 400 times sine of 15. I'm going to end up multiplying these together and get A times 145. So when I type in my calculator, I'm taking 400 times the sine of 45. That's not 45, it's 15, excuse me. Let's back that up, make that 15. Okay, and then I'm going to divide that by the sine of 145. And that gives me 180.5 feet. 180.5 feet. Now, I still haven't gotten the height of the tree. I now have to do old school geometry. And I've got to use this 20-degree angle with my opposite and my hypotenuse. So the height of the tree is actually the opposite side. So this is old school sine. So I'm going to take the sine of 20. And I'm going to set that equal to the height of the tree, which I'll call H, all over the hypotenuse, which is 180.5 feet. And just cross multiply, so the height is going to equal this product. So let's grab the calculator and take the sine of 20 times 180.5. And that's 61.7. So that means the height of the tree is 61.7 feet. So in summary, let's go to the bottom. Let's write up what our answer is. The tree is 67.1 feet tall. And so let's summarize. I'm going to want to go back and summarize anyway, kind of what we did here. Now, what we did is we drew the picture, given the information. We had angles of elevation. We drew the distance between the two people as 400. Then we had to find angle C, which was 145 degrees, and use it with the law of sine, where 400 is side C, and it's associated with the sine of 145. So we set up that ratio. C over sine 145 is equal to, and I solve for A. You could solve for B and then work your sine over here, but I chose A. And I solved for A, and I found that to be 180. Then I used old school trig, just a regular sine function, to solve for that final one. So there you go. That's how you can do applications. So you're going to be drawing some of your pictures and answering some of those questions. Those directions I went over should help you do that. Good luck, and thanks for watching.